Alright, let's bring it all together to graph rational functions. There's three main things you want to do when graphing these functions. One, find any asymptotes and holes in the graph. Then you want to find your x and y intercepts. Lastly, pick some points that you can plot on the graph. These are going to be very important. You're going to have to be strategic about picking these to help you discover how the graph behaves. Alright, let's go on to our first example. Here we've got f of x equals x plus 4 divided by x minus 3. First, let's look for our asymptotes. For a vertical asymptote, remember this is what is going to make the denominator 0. In this case, it would be 3. So we've got a vertical asymptote at x equals 3. And I'll go ahead and put that right on our graph just so we don't forget about it. X equals 3. Horizontal, we need to look at the degree of the numerator versus the degree of the denominator. These both have a degree of 1, which means they have the same degree, so we'll take the coefficients of those, and that's going to give us a y equals 1 over 1, which is 1. Alright, I'll go ahead and put that on our graph as well. We've got an asymptote at y equals 1. Alright, next, slant asymptotes. Since we already have a horizontal asymptote, we know that slant asymptote is not going to be the case. Okay, looking for our x-intercept. Our x-intercept, remember, is where y equals 0, so we can go ahead and solve for that. Let's do 0 equals x plus 4 over x minus 3. Now I want to show you something. Whenever we want to solve for this situation here, we'd multiply by x minus 3, multiply by x minus 3, and we'd end up just getting 0 equals x plus 4. So when searching for your x-intercept, all you have to do is take what's on the numerator and set that equal to 0, since the denominator is going to cancel out anyway when we multiply it by 0. And in this case, we're going to end up getting an x-intercept at negative 4. Alright, looking for our y-intercept. We want to see what y equals when we plug 0 in for x. So that's going to give us y equals 0 plus 4 over 0 minus 3. And we're going to get y equals negative 4 thirds. So our y-intercept, negative 4 thirds. Now this is where it gets very interesting. We want to take our x and y-intercepts. Let's go and just plot these on our graph so we have those points. We have an x-intercept at negative 4. We've got a y-intercept at negative 4 thirds. Would probably be somewhere around here. It's alright to do an estimation. Remember, we're just graphing these. It doesn't need to be perfect. Now once we have points on our graph, what we can do is we can draw lines that approach the asymptote. So this goes through the points, but it's going to go right alongside the asymptotes here. So we really don't need to plug in a bunch of other points over here. On this side of the graph, though, on the right side of our vertical asymptote, we don't know whether the graph is going to go like this or whether the graph is going to go like this. So, in order to find that, we definitely need to pick a point on the right side of the graph. I'm going to go ahead and pick x equals 4 since I see that 4 is on the right side of our vertical asymptote. So if I say x equals 4, let's plug that in. That'll give me y equals, I'm just plugging that back into our original function here. That'll give me y equals 4 plus 4 over 4 minus 3, which is going to be 8. So at x equals 4, y equals 8. So let's go ahead and plot the point 4, comma 8. Here we go. That's going to be 4, and 8 is going to be somewhere up here. That's just 4, 8. It doesn't really matter if it's perfectly accurate. Let me make that blue to match the rest of my graph. Alright, now that we have our point there, we know which direction our graph is going to go based on the asymptote. It's going to go on top of these vertical asymptotes. So what I can do now is I can just fill that in. I can put it through my point here, and I know it's going to be going up in that direction and to the right over here. And there we have the graph of f of x equals x plus 4 over x minus 3. Alright, in our next example here, we want to find our vertical asymptotes. What's going to make this denominator 0? That's going to be 4x squared plus 1 equals 0. Solving for this, I'm going to get x squared equals negative 1/4. Remember, and when I square root both sides here, I can't take the square root of a negative, So I know that I'm not going to have a vertical asymptote. So there's going to be no vertical asymptote. To find the horizontal, let's go ahead and compare our degrees here. We have an x squared on top, x squared on the bottom. The same degree, so again, we're going to take the coefficients. And here, 8 over 4, that's going to give us a horizontal of y equals 2. Again, there's going to be no slant asymptote because we do have a horizontal asymptote. Finding our x and y intercepts, you're going to find that we have no x-intercepts and we get a y-intercept at 5. I'm going to go ahead and plot what we know so far. Our horizontal at y equals 2. We've got a y-intercept at 5. I'm going to go up here to 5. Alright, now there's not too much to go on for our graph, so I'm going to go ahead and pick a few points. I know that my graph's going to have to approach the asymptote, but I'll go ahead and pick a couple just to be sure. I went ahead and got the points negative 2, 2.17, and 2, 2.17. So if I graph those are going to be somewhere around here, and just tracing my graph, I see that it's going to always go towards the asymptote on either side through those points, and there's my graph. Okay, let's do another one. F of x equals 3x minus 2 over x squared minus 9. To find our vertical asymptotes, we need to find where the denominator equals 0. I'm going to go ahead and factor the denominator because it's going to be a little easier. And I'm going to get my vertical asymptotes at x equals 3 and x equals negative 3. My horizontal asymptotes, as you can see, my bottom degree, my degree in the denominator is bigger than the degree in the numerator. Therefore, I automatically have a horizontal at y equals 0. Since I have a horizontal, I'm not going to have a slant asymptote. Once again, finding my x and y intercepts, you know what to do there. I'll go ahead and put those in. We get a x-intercept at 2/3, a y-intercept at 2/9. All right, let's plot what we have. Our vertical asymptotes are at negative 3 and 3. We've got a horizontal at y equals 0. We've got our x-intercept at 2/3. It's going to be about here. Oh, sorry, that's a y-intercept. My x-intercept is going to be at 2/3. That would be about here. And my y-intercept is going to be at 2/9, which would also be about right here. All right, I want to show you something that happens when you have two vertical asymptotes. Now I know we said we can never cross an asymptote, but when you have two verticals, you actually can cross the asymptote in the middle of those two vertical asymptotes. So sometimes you're going to get a graph that looks like this. Sometimes you're going to get a graph that goes through the middle, like something like this. It just depends, but it's going to be important to pick points that are going to help you determine. So I always pick a point close to the left vertical asymptote and close to the right vertical asymptote. Go ahead and pick some more points to fill in the graph. I went ahead and picked my x values very strategically. I picked negative 4 because it's to the left of this vertical asymptote. I picked 4 because it's to the right of this vertical asymptote. And then I went ahead and picked negative 2 and positive 2 because I want to determine whether or not this graph is going to go and make a U going up this way, or if it's going to go through the x-axis and cross that horizontal asymptote. So I'm going to go ahead and plug these in and find my y values. Alright, we have our values down here. I'm going to plot these points. I have negative 4, 2. That's going to be about here, which means on this side it's going to go above my horizontal asymptote, approaching each one. Alright, I'm going to go ahead and move to this one. I have 4, 1.3. So if I go over to here to 4, 1.3 is about here. This side is also going to be on top, and it's going to cross that point and approach both my asymptotes. Alright, here we have our middle points. I got negative 2, 1.6. That's going to be about here. Negative 2, 1.6. And I've got 2, negative 0.8. So if I go to 2, that's going to be at negative 0.8. Alright, we can tell based on having one value above the horizontal asymptote and one value below the horizontal asymptote that it's going to cross. We'll just go through our points and remember we're approaching those asymptotes on both sides. All right, last one. You've been doing so well. Hang in there. Let's start by finding our vertical asymptotes here. That's going to be where our denominator equals 0. Let's go ahead and factor. This is going to be x plus 4, x minus 3. So our vertical asymptotes are going to be at x equals negative 4 and 3. Looking for our horizontal, let's take a look at our degrees. Here we have a degree on the top of 3, a degree on the bottom of 2. So in this case, since the bottom is 1 less than the top, we're going to have a slant asymptote, which means we have no horizontal asymptote. Let's go ahead and find that slant asymptote. Remember, to find the slant asymptote, we want to go ahead and do a long division problem. We'll have 2x cubed divided by x squared plus x minus 12. I'm going to go ahead and put in my missing terms just to fill in the space. Let's give ourselves some room here. If we solve this problem out, we're going to go ahead and get 2x minus 2 for our first term. So our slant asymptote is at y equals 2x minus 2. Our x and y intercepts are both going to be at 0. Let's go ahead and plot what we have. We've got x equals negative 4. We've got x equals 3. We've got y equals 2x minus 2. My y-intercept's at negative 2, up 2 over 1. So my slant asymptote is going right in there. And it's going to be important. Let's give ourselves a little bit more room because we're going to want to see where these cross down here. So I'm just extending our graph just a little bit. All right, and from there, let's go ahead and give ourselves, let's find some additional points that we can plot and find out where what is happening. Let's start by picking negative 5 since that's on the left of this vertical asymptote. If I plug in negative 5, I'm going to get negative 31.25 for my y value. That's going to be well below our slant asymptote. Remember, it's not so important that this is exactly in the same spot. We only want to gauge the behavior. And since it's on this side of the slant asymptote, we know this line is going to go like this, approaching both asymptotes. Remember, it's okay to estimate. We just want the sketch. Next, let's take a look at this middle region. Remember, we don't know if it crosses this middle part or not. So let's pick an x value on either side of this middle section. I'm going to go ahead and pick negative 2, and why not positive 2, just for good measure. I'm going to get the y values of 1.6 and negative 2.6. Let's go ahead and plot those on the graph. 2 and negative 2.6, somewhere around here. Oh, and I actually forgot to put my x and y intercept at 0, 0. I'll go ahead and do that. So I know this middle section is going to go through that asymptote. Lastly, let's pick something on the right side of this asymptote. I'll go ahead and pick 4. Giving me a y value of 16. Plotting that point, I could see that it's also going to be well above that line, somewhere way up here. I don't necessarily need to draw that graph. All I know is it's going to go do another one of those guys, staying really close to those asymptotes. If it was on the other side, say I plugged in 4 and I got 2, then my graph would look something like this. But that is not the case here. So in graphing these, it's not too difficult. Just find your asymptotes, find out which side your graph is approaching, whether it's on top of asymptotes or below, whether it's going through the middle or making one of those U's that we talked about. And again, it's okay if you're not perfectly neat. We just want to sketch the graph. We just want to get an idea of what it looks like. For your homework problems, you're also going to be finding the domain of these. I want you to do some extra practice. Mostly it's just going to be excluding x values. So make sure you're reviewing and checking your answers on those. Email me if you have any questions.